So a few things here to take a look at. So I sent you guys an announcement here. And what I created for people to let people know is I sent a lot of different announcements, but you have what's called like a limit review. Is that right? So those are some things that we're going to go over here. Well, sort of. You got a limit review, and you got a limit review like reminder, I guess. And they're also on my website. You got to find 261. Okay. And it's down here, the new. So I'm actually putting this together in case you guys didn't know. All these are kind of lectures that we went over: limits with polynomials, rational functions, vertical asymptotes, limits with removable discontinuities, limits with piecewise function. This is the same limit review that I have here. And then over here, I have the limit review reminder, these here. So I put some reminder here of this information. Hopefully that's useful. Did anybody take a look at that and find that useful? Hopefully. Because again, I think the expectation at this point is that you guys can be able to do these questions right here. Okay, that's the expectation. And these are actually some questions that we've actually some of the ones that we've worked on. Okay, I'll probably try to get up a solution sometime soon. But that, again, I would recommend that you go back, and sometimes students will say, hey, I don't know how to do any of these things. It's like, well, you got the lectures here. And then you got some work on 2.3 and 2.5. We got to talk more about some more limit examples. And so that's what I'm going through today. I even have another worksheet called limit examples. And I believe here you have a lecture on that. I'm not going to do the same ones. I want to do some different limit examples. So some of this is about putting everything together for you, so there's more work that we have to talk about with limits. There's a lot more stuff to work on this week. Okay, and also, I think I did get this from someone. It may not have been in this class. Sometimes, let's go back to 261. Sometimes students say to me, hey, Mr. Judge, I don't know how to do anything. What's going on? Is there any tutoring? So, yes, there's tutoring where? Where do you guys get the tutoring at? Well, there's two places. You guys are lucky that you have an SI coach. So if your schedule matches that, I think there's communication with the SI coach. That should be very helpful. But, your schedule may not match up. And so you do have the what? The walk-in tutoring lab. And those are the hours. They even have Zoom hours for you. Okay, so you have that option. The reason I point this out because office hour options for me are limited. Is that right? They're only for like 4 days a week, and they're not as long as what you guys see here. So that's kind of what's going on. We got some work to talk about, right? So anyway, if you said, how do I do any of those examples here, stuff that I'm supposed to be able to do by now, I don't know how to do any of these. Well, then watch the video or stay tuned for the solutions that come. Okay, yes, you could come to office hours. Yes, you can ask the SI. Yes, you could ask the tutoring lab. So there is resources available to help you. And I even sent, I believe, other things via the announcement I asked you guys to work on because they're going to be very helpful, like some algebra review. You're going to see some of that today even. So you say, well, what am I going to see today? Well, what I have here is this. Let me go back, because I'm using multiple computers. Where is it? Okay. So they're going to ask you, for example, just take the limit. Now I'm going to kind of make one up. Yeah. Limit as x goes to 2. I'll say x plus 2 over x cubed plus 8. Yeah. Okay? Now let me be careful here. I think this will be minus 2. Is that right? Okay. All right. You guys okay with this one? I think this one's okay. Yeah. Now, what would you guys try to do here with this? If they're just going to say to evaluate the limit, right? So how would you try to evaluate that limit? What would you try? I mean, yeah. You might, but you might, sometimes people look at this and they go, you know what, I'm going to try to evaluate, they're going to think maybe this is nice and continuous. Is that right? And then what do you guys notice when you do that? If you assume it's continuous and you just plug in -2 wherever there's an x, is that right? What do you get? 0 over 0. Good. So if you assume it's continuous and do functional evaluation, right? What's the problem? And what is this? Because you guys want to know what this is. You definitely want to know this. Because there's going to be a lot of examples that you see that say just evaluate the limit, that you'll run into this situation. So what do we know about this? What did we call this last week? It was indeterminate. Good. What does that mean to be indeterminate?
You can't determine that.
You can't determine. Is that true?
Yeah. It means it's like it's a whole.
Well, it means something, but it just at this point what we say is we just can't determine. So I'm just going to go through the thought process that some people go through. Okay, you guys with me on that? This is the thought process that people go through. So at this point, you go, okay, that's the thought process that people go through. 0 over 0, it's indeterminate. You know what that's code for? I would say this. If you ever get that indeterminate form, go back to the function. I know it's rational. That's code for using some what? Algebra. Okay? So it's code for algebra. And then you might say, well, what kind of algebra is this thing code for? Right? What algebra are we even talking about? Well, what's the only algebra you can actually do? The only algebra you can do is in the denominator. And what we mean by that, this is going to be a case of what? Yeah, special factors. What's that called? Sum of perfect cubes. So, I mean, the kind of things that I want to go over today is some of these little details that you might be running into. Right? So these are some of the details that people are going to run into. They go, wait a minute, how do I evaluate that limit? I don't know how to do that limit here. Right? Okay. Well, I showed you guys that beginning algebra factoring video. Is that right? Okay. So what I want to share with you guys is the algebra they want you to do here is this. The sum of perfect cubes. 8 is a perfect cube because 8 is written as 2 cubed. Right? So then now you say, okay, what's this? X plus 2. This is going to be what? X plus 2 over x squared. Is that what it is? I think so. X squared minus what? This is 4. I think that's minus 2x. And this is plus 4. Is that true? So you're going to have to factor special factors, and then what goes away? The x plus 2, and then you have x squared minus 2x plus what? Plus 4. So this question is really the limit now, as x goes to negative 2, of 1 over x squared minus 2x plus what? Plus 4. Okay. And then what are you guys going to notice that you can do now with this? And, yep. Yep, absolutely. Now, guess what's going to happen? If you plug in negative 2 wherever there's an x, you get what? 1 over negative 2 squared minus 2 times negative 2 plus 4. Or you get 1 over 4 plus 4 plus 4, which gives you 1 over what? 12. Okay? So, ladies and gentlemen, take a look at this. You know, I'm trying to look at the book. I didn't bring that with me, but I think I have some of it here. Yeah. This is how you start to answer some of these questions. Is that right? Yes.
How do we come against like a similar problem like that, but it has like radicals?
Well, we're going to see more examples. We're not just going to jump to that. Okay? You guys okay with that? All right. Okay. So I'm going to go through, like I said, some of these limit questions. Let me give you guys another one, for example. They could change the variable. They have h goes to 0. Maybe 2 plus h minus 1 minus 2 to the negative 1 over what? Over h. So if we take a look at this particular question now here, h goes to 0. Is that true? So a lot of times students look at this and they say, I don't know what to do, so they assume it's continuous. So they try to do what's called functional evaluation. And then what happens now? What do you guys get when you do that? Do you guys know? You say, is that 2 plus 0 to the minus 1/2 minus 2 over 0? And then what's this negative 1/2 mean? Do you guys know?
It's a fraction.
Yes. So what I'm getting at with these is this. These are the limits that you're going to have to do some what? Algebra with. Is that true? All right. That's really what I want to say. You're going to use some algebra. Now, this is going to, again, give you what situation? 0 over 0, and that's going to be, what is this one? Is that indeterminate? So this is indeterminate. What is that code for doing then if it's indeterminate? You got to use some what? Use algebra. All right. So we're going to use this algebra here. Okay, so then by some algebra, you might look at this and say, well, what's the only algebra I can use? Well, use the definition of what? Use the definition of what it means to be the negative 1 power. This is some algebra. And the algebra that you can use now is only what? What's the only algebra you guys can use, you think? Anybody know? What's the only algebra you guys can use? What are you looking at? Do you guys know? The only algebra that you guys can do is to subtract the two rationals. So if you said, the only thing that we can do here, there's no factoring here. And this is going to be a big deal. This is going to be important for us. So the only algebra you guys can do here is subtract the rationals. Now, there's a nice little algorithm that you can use here. Do you guys know what I'm talking about? Let me write it down here. If you have A over B, it's really plus or minus C over D. So what am I actually talking about here? You guys know what I'm talking about? You can do what? You cross multiply, and then you multiply across here. So this would be AD plus or minus BC over BD. So in gray, you have this portion, and then in gold, you have this portion. So what does that mean for us here? Well, that means we multiply these two, cross multiplication, and then we have a new denominator. So doing the algebra, we get now what? 2 times 1, which is 2, minus the 2 plus h, okay, over 2 plus h times 2, everything over what? H. Okay? So just take a look at that. That's what I'm talking about. We got some algebra to work on today. And that's going to help you answer some of the questions from 2.3. Is that true? You guys know what I'm saying? So we got to work on some algebra. Alrighty. Now, here's what you guys want to do. You want to simplify what you have. So this gives us 2 minus h if I distribute. Is that right? Over, I'm going to just switch my 2 and the 2 plus h. I'm going to say I'm dividing by h here. Okay, so this is negative h now over 2 plus h times the 1 over h. Okay, whenever you divide by a whole number, you multiply by the reciprocal. So now we multiply straight across 2 plus h times h, and then what happens here with your h's? They cancel. So this is now going to be just minus h over 2 plus h. And what was that limit? As h goes to 0. So you're going to now take the limit here as h goes to 0. Okay? Yeah. No, the h's go away. I'm sorry. That's going to be a 1 now. Yep. Thank you so much. Yeah, I was looking at that, and I'm going, wait a minute, something's wrong. Okay. So notice what just happened. When you get the indeterminate form, you're going to have to use some algebra. Okay. So now, what do you guys know? What happens now with this? Just plug in the h value. What do you get? Plug in 0 for h. What do you guys end up getting? It's negative 1 over 2. 2 plus 0. What does that give you? It'll be negative 1/4 as a final answer here. Okay, double check. Does anybody have any questions on this one here? Right, so this is some of the questions from like 2.3, how you go about them using some of the algebra. All right, anybody? Yes?
Will that be considered continuous?
Actually, continuous where?
The answer you got.
This is just a limit. We just evaluated the limit. So all we did was evaluate the limit. That's what they're just asking, just evaluate the limit. And you're going to be all of these limits that they're giving you to evaluate, they're not going to be continuous. So every now and then, they might give you a nice continuous situation, so you have to be awake. That's the whole idea. But what I'm looking at, even at the worksheet that I did, just to kind of show you guys another one here, like another example. Limit x goes to 4, x squared minus 4x over x squared minus 3x minus 4. Okay, so like I said, they're only going to ask you to evaluate this limit. Yes?
What is the x squared minus 3?
Minus 3x minus 4. Okay. So how do you evaluate this limit is the real question. If you assume it's continuous, right? Let's say you guys assume it's continuous. What does that mean to assume it's continuous? If you plug in 4, what happens by plugging in 4? You're assuming it's continuous. What do you discover here? What does that give you if you assume it's continuous? Meaning you just plug in the 4. You get 0 over what? 0. Is that true? Okay. So what does that mean? Indeterminate form. Good. And indeterminate form means we just can't determine. Okay, so that's what you're doing here. So if that's the case, what do we say you have to do now? You have to use algebra, and then that's going to be the deal. Okay? That's going to be the deal. What's the only algebra that you can do here? Factor? Is that true? You have a rational function, so you want to factor both numerator and denominator, meaning x squared minus 4x over, you got what? X squared minus 3x minus 4. So the only algebra you can do is actually a factor and simplify the rational, because you have a rational function. So the only algebra that you can do is factor. Now, if you factor the numerator, what do you guys get? X times x minus 4. Is that true? You're factoring out the greatest common factor, right? That's beginning algebra. And then it's also beginning algebra. How do you factor x squared minus 3x minus 4? You could use the crisscross method. Is that true? So use the crisscross method. When I sent you guys that video over Labor Day, did you guys take a look at that? What method did I use there? Crisscross? That's why I sent that to you guys. That's one of the reasons. Because this is what's going to separate people who move forward and people who don't. It's going to be the algebra. So I sent that to you guys, some of the algebra early. So, okay. So how do you guys factor this? Do you guys remember? What does this become? Is that x minus 4 times x plus 1, okay? Now, what cancels? The x minus 4. What are you left with? X over x plus 1. So they want the limit as x goes where? To 4 now. So you get the limit, x goes to 4 now. And then what's that going to do? Now you get to plug it in again, because what do you know about this rational function now? This rational function is actually continuous at what? At 4. Is that true? Do you see what I'm saying? The book calls it direct substitution. It says just directly substitute. So then you got a nice rational function continuous at 4, which means just plug it in. And what do you guys end up with? This is 4 what? 4 over 5. all for using what? Algebra. Okay, everybody okay with that one? I'm going to try to create one here. Let me just give you guys a note here. Or by the way, what they can do sometimes, you have to be awake here. They're going to tell you to evaluate the limit, but they can say evaluate the limit as x goes to 0. Okay, so just note, what's the story now? If you plug in your 0, what do you guys know about this? If you plug in that 0, you get 0 over negative 4. Is that indeterminate?
No.
That's determinate. What's 0 divided by negative 4? So, ladies and gentlemen, this limit equals what? 0. And that's because the function was continuous at 0. So, I mean, just to kind of remark about that, that was because f is continuous at 0. You might say, well, how did I even know that? Well, when we simplified, what do you guys get? You got this function here, right? And that function was continuous at 0. So anyway, I just want to compare and contrast. That they might check to see if you're really awake. Do you even understand the indeterminate form being 0 over 0? Some people do, some people don't. And that's what they're trying to distinguish. Do you know that this is not 0 over 0? That it's 0 over negative 4, which is determinate? 0 over 0 is not determinate. So that's kind of part of the test, if you guys want to think of it that way. That's what they're testing you on. And then another example, so we're going over these kind of limit kind of questions you guys can see here. They might have a limit, let's do again, limit as h goes to 0. How about x plus h squared minus x squared over h? And then what do you guys discover as you apply that limit? This is the limit now with h going to 0. So wherever there's an h, you plug in a 0. Is that true? So you notice you end up getting, you say x plus 0 squared minus x squared over 0. What do you guys end up with again? 0 over 0. What do you guys know about that? Indeterminate. Is that true? Okay, all right. So since it's indeterminate now, you say, well, I guess the only thing I could do now is use some what? Just use algebra. So the only thing you could do now is use some algebra. Although now you might say, what's the only algebra that you can do? Yeah, you look at this and you say the only algebra we can do here is really simplify that numerator here. And how you simplify the numerator, what is it called? You guys know what I'm saying? You got this x plus h squared. What's that called? It's called expanding, right? So you're going to have to expand here. And how you expand that, you just use the definition of what that is. That's x plus h times x plus h. Is that right? So the only thing you can do to expand is to use what? FOIL. By FOIL, you get what? X squared. Yeah, you could say plus hx plus xh plus h squared minus x squared, everything over h. And then this is actually x squared plus 2xh plus h squared minus x squared over what? H. What happens now? Just your x squareds cancel. So you now have 2xh plus h squared over what? H. Okay? Well, yeah, you're not done with, what's that word again? With the algebra, meaning, can we factor out an h for the numerator?
Yeah.
Yes. Now, what happens with the h's? Cancel. So you're just left with what? 2x plus h. Okay. So, ladies and gentlemen, go back here. They want the limit as h goes to 0. So this is going to be the limit as h goes to 0. So you might say, well, what are we looking at here as a function? Okay, what you guys are looking at is really what's called a polynomial function, but in two variables. With x and h variables. They're two variables. They behave just like regular old polynomials, meaning you replace h with what? With 0. Is that true? And you just end up with, you say, is this 2x plus h? It is, or it's not 2x plus h, 2x plus what? 0, which is just what? 2x. So you did end up with a polynomial into what? Variables. So this is not a number, it's a function. And this is going to have meaning for us in the future. But they give you guys some limit questions like this now. Okay? So I want to kind of remark about some of these things in case you guys haven't noticed. In every case of the indeterminate form, when you did your algebra, everything worked out nicely. Is that true? Okay? In fact, when you had h's on top and bottom, the h's went away. That's going to happen in our future. So we're going to work on these kind of limit questions. They're very special limit questions. Does anybody happen to know what kind of limit questions these are? It's okay if you don't. But I know the author of the book throws in some of those questions now, so I'll do the same. You know. So did you guys see some of those questions in 2.3, I guess, some of these? Yeah. Okay, now let me give you guys another limit example. These are some examples sometimes that get students the most, maybe. So I'll work on one here that I already have done. And when you actually try to evaluate the limit again, what are you guys going to try to do with this x? You're going to try to plug it in, right? 2. And what do you guys notice when you do that? Did you guys notice anything? You get the square root of 4 times 2 plus 1 minus 3 over 2 minus 2. Is that true? And then that's the square root of 9 minus 3 over 0. And the square root of 9 is going to be what? Isn't that 3? So what are we seeing here? You're really getting what again? 0 over 0. So then the question now becomes, well, what do you do if you have 0 over 0 again? You got to use some what? Algebra. Good. You're going to use algebra. So if we focus on that, you say, I see this radical. And if you're going to try to use algebra on that rational-ish kind of function, what kind of algebra can you guys use here? Can you expand? No. Can you use FOIL? No. Yeah. The only algebra you guys can use is, you guys, some of you guys already know, rationalize the numerator, which is done by using what? Conjugates. So in my mind, when I see this, you guys want to think of it this way. The reason I'm going through all these different settings is because the algebra is different for each one. Do you guys see what I'm saying? In some cases, you're going to be able to factor. They're factorable. In some cases, you expand. Like they can give you a cube. I have a video of limit examples for you guys. I don't want to do all those examples. I want to do different ones because then you could go back and look at the additional ones and you have now what? A whole wealth of examples. So you can expect, this could be a cubic. You know, you could have different factoring here. So, and then you could, then you can have, you know, the subtracting of rationals using this algorithm. So what you see is different. Yes, this is known as rationalizing the numerator. And I do have intermediate algebra videos on that, by the way. I do have intermediate algebra on working with conjugates. So if you go to my intermediate algebra, you might say, boy, where is it? Intermediate algebra videos. Yeah, go all the way down. It's really down here with rationalizing, radical equations. Where we are going here. It's some of there. It's rationalizing radicals. Or dividing by, let's see, where is it at? Maybe sooner? Yeah, I'll have to look for it. It's really under here, dividing radicals, and we have rationalizing the denominator. You could rationalize the denominator or rationalize the numerator. It's the same process. You use conjugates. So it's even there. So again, if that's something you guys need to review, I say review. But let's go through and do this kind of thing, okay? So if you said, well, what does that even mean? Well, to rationalize, you guys have this irrational. It's a square root. We got to use the conjugate. Do you guys remember what the conjugate is? It's the exact same thing that you see here as a numerator. So you're going to put the square root of what? 4x plus 1, but you got to just change the sign. So the only thing that's different is the sign here. And you're just going to multiply. Okay? Now, the only way you can actually do this, the only way we can preserve equality is if the denominator is the same thing, square root of 4x plus 1 plus 3. Okay. So what happens when you do this? You guys know? By FOIL, anybody know what happens? What's the square root times that square root? So the first term? Yeah, well, it sort of can't, you're just left with whatever's under the radical, 4x minus 1. And then you just subtract what? 9. You say, what happened to the O and I terms? They go away. That's why you use what? Conjugates. That's why conjugates are amazing. The O and I terms go away when you use FOIL. I mean, that's it right there. And then the denominator might just be, you know, it might be just pretty hairy. You say, okay. But you're going to use your conjugate now. So all that simplifies now is the 4x plus 1 minus 9 is really going to be now 4x what? Is that minus 8? Right, for the numerator. Then you get x minus 2 times the square root of 4x plus 1 plus 3. And then if you factor the numerator, isn't that 4 times what? X minus 2. And you got the x minus 2 down here. Square root 4x plus 1 plus 3. What happens to the x plus 2's? Right? They're gone. Is that true? So you got 4 over square root 4x plus 1 plus that 3. Double check to see if we've made a mistake or not, right? Okay, now what is this limit going to be? Limit as x goes to 2. So can we evaluate this limit now by functional evaluation or direct sub? I think we can. Is that true? So now this will be 4 over the square root of what? 4 times 2 plus 1 plus 3, which is 4 over the square root of 9 plus 3. What's the square root of 9?
3.
So this would be 3 plus 3, which gives you 6. So you get 4, 6, or really what? 2/3. So ladies and gentlemen, like I said, you're going to see different situations where the algebra is different. If you have a square root like that, you got to use conjugates. Okay, anybody have any questions on this one? This is where you guys want to ask questions. Right? And then let me remark about this. Why is this exactly the same? Because it equals 1. Good. Anything divided by itself is what?
1.
The number 1. And you can multiply 1 with anything. It preserves equality. Yes. That's rationalizing the what? The numerator using conjugate to the radical. And that will show up every now and then. You'll see that one. Anyway, okay. Anybody have any questions on that one? No? Yes. All the way up here? Okay. And remember, I have these videos there for you guys. Does anybody ever go back and watch them by any chance? Okay. So you guys know where they're at, right? They're under the lecture portion in the module. Okay. All right, good. All right, how about this? Let's see what you guys work with this one here. I'm just looking at maybe x goes to negative 2. 2 plus x. 2 minus the square root of x. All right. Okay, you got to evaluate the limit. What do you guys notice about this? Well, you get 2 minus the absolute value of negative 2 over what? 2 plus negative 2. And the square root of negative 2, or I'm sorry, the absolute value of negative 2 is 2. So I'm going to get what again? 0 over 0. Okay. Indeterminate. Is that true? Can't determine. All right. Now, we're supposed to use here algebra. However, what's the story here? Anybody know? Well, there isn't any much algebra we can use. Remember this, the only thing you guys can use is right in here. What's the definition of the absolute value? It is x when x is greater than or equal to 0. It's opposite x when x is what? Less than 0. Is that true? So what you're going to need to know is what's happening with this limit. X is going to negative 2. What does that mean if x is going to negative 2? Around negative 2, the x values are what? Aren't these x values negative? So around negative 2, whether it's the right or the left, around negative 2, the x values are negative. Is that right? So what that means then is I replace the absolute value with what? Negative x. Okay, so you go, okay, then that means 2, right? What does that mean? That's going to be what? 2 minus a negative x over 2 plus x, yes? And that's the limit as x goes to negative 2. Okay, let's do some more algebra. I mean, I don't have to do that yet. I'm going to do some more algebra. What's 2 minus a minus? 2 plus x over 2 plus x, which is really the number what? 1. What's the limit of a constant function?
1.
The constant, is that right? Remember I gave you that limit review sheet? Yes. Was that fact there, the limit of a constant's a constant? So, ladies and gentlemen, a part of this really comes down to reading the absolute value function, knowing the definition of it. You know. And that's all, they want you to do. And I'm kind of looking again at some of these questions. What if they gave you the limit, maybe of x goes to 1 of x squared minus 1 over the absolute value of x minus 1 here. All right, so when you try to evaluate the limit, what do you guys get again? Is that 0 over 0? And that's indeterminate again? Okay, you guys okay with that? Do these kind of look like some book questions? Do they look like 2.3 questions maybe? And you go, oh man, so okay. Now let's look at a detail here. Here's a detail. This is the limit as x goes to 1. When you try to plug in 1, you get 0 over 0. You think it's continuous, and it's indeterminate. Okay. So, like we said, if that's the case, you got to use some what? Algebra. So, we need to know a definition here, okay? So, I'm going to give you guys the definition. First of all, 2 things. We're going to have to look at the limit as x goes to 1 from the left and the limit as x goes to 1 from the what? From the right. Is that true? Why do I have to look at both directions?
Because it's absolute value.
Well, no. You're looking at the reason right here. Right? They're vague. Yes,
Why didn't we do that with the previous question?
because we didn't have to.
So, but since you just said -2, so.
Mhm. We didn't. This is a very good question. Don't think just because you have absolute values, they're all done the same exact way. They are sort of. This is a different kind of absolute value, right? So this is limited as x goes to -2. What I'm getting at is I use my definition of absolute value. And by the definition of absolute value, I just get the limit being a constant. Now, if you said, well, why don't we just do that too? Okay, then let's get rid of this. And then I'm going to have to ask, what's the definition of the absolute value of x minus 1 then? You said you just used the definition prior. Okay. How do you define the absolute value of x minus 1? Now you have to do it piecewise. Okay, you got to do it piecewise. So I'm going to give you guys a fact. It's really the definition, right? But I'll give it to you this way. The absolute value of anything is going to be what? Itself, when what's between those lines is greater than or equal to 0. Its opposite self when it's less than 0. Okay? This is a very important fact for you guys because they're just not going to give you the absolute value of what? Of x. So in calculus, they start giving you these absolute values, but they're piecewise functions that are studied in a pre-calculus course. So that the absolute value of x minus 1, how do we apply this? Do you guys know? You just say it's x minus 1, right? Whatever is between the absolute value signs. It's just x minus 1 when what? X minus 1 is greater than or equal to 0. Or its opposite what? X minus 1 when x minus 1 is less than 0. Did I use exactly what I'm giving you here? This is, by the way, the definition. Okay? The only thing you guys want to know is this. What does this mean? And then what does this mean? Right, what do those two things mean? Does it mean x is greater than or equal to 1? In other words, you have what's called a simple inequality. You can solve for x for both of them. And down here, if I distribute, okay, I'm going to distribute. I'm going to get negative x plus 1. And this means x is less than 1. So this is what you're going to use here in terms of what we say, the algebra. All right, you guys okay with that? So, go back to the original limit question. Why did I say here you got to look at both sides of this limit? Right? How do I know? I'm going to have to look at both sides now. Because it's a piecewise function, and they very strategically did what? They asked you for the limit around 1. And this piecewise function changes for x values around what? 1. You guys see that there? So they were strategic with what they did. And they're going to do that a lot of times because they want to test you. Hey, do you even know how a piecewise function behaves and works? So that's kind of the idea. Oh, how does a piecewise function behave? How does it work? So using the definition of a limit now, because this is vague, the limit as x goes to 1 from the left of the x squared minus 1 over absolute value x minus 1, that function, what do we have to know? There's another piece of information we got to know. This is probably going to get some people, because like I said, they're really testing on whether you can read a piecewise function. So what do I mean by that, right? I'm going to change colors here. I'm going to use this as orange. Orange is my top piece, and then green is the bottom piece. So orange is the top. Green is the what? Bottom. Can you guys read a piecewise function? Well, here's the test. If x is going to 1 from the left, what do you guys know? What does that mean?
The numbers are less than 1?
It means x is less than 1. Remember you guys looked at the numerical approaches to limits? See what I'm saying? How it all fits? It's not a coincidence that they show you first numerically and you go, oh, I'm approaching 1. So this is this is called a left-handed limit. What does that even mean? If x is smaller than 1, oops, I used the wrong color. If x is smaller than 1, use the what piece? Use that green, the bottom. And the bottom, you can say, is that, what's that going to be? Well, I can write that as 1 minus x. You know, sometimes we do that. So this limit question, it's a left-handed limit. That's the limit. As x goes to 1 from the left, the numerator is factored as x plus 1, x minus 1. And the denominator is just 1 minus x now. Okay, you guys okay with that? Okay, you guys see my point? Now, I guess I have to do one more thing, unfortunately. What do I have to do? Anybody remember? It's still an intermediate algebra-ish or a pre-calculus thing. Factor out a -1. From what? Yeah, I could say factor out that -1, and in fact, I could have just used what I had here. Do you guys know what I'm saying? We could have just left it alone. We didn't even have to distribute. Isn't that the bottom piece? You guys know what I'm saying? We could have just used that bottom piece, and then that bottom piece goes right in here then. So you go, oh, why don't we just leave it alone? Well, okay. Now, why is that a good idea? Do you guys know? Cancel. Good. Now, this is the limit as x goes to 1 from the left of x plus 1 over -1, I guess. And what's that going to give you? Isn't that a nice continuous function? It's a polynomial, by the way. I didn't do the algebra, but I'm going to now plug in what here? 1. Good. And that'll be what? 1 plus 1 over 1, 2 over -1. That limit is -2. Okay? Now, we're not done because we need to know what? We need to know the right-handed limit. You go, okay. So this would be the limit. X goes to 1 from the right now. And that's x squared minus 1 over the absolute value of x minus 1 here. Okay. But if you're going to 1 from the right, what do you guys know about the x values in relation to 1? Are they bigger than 1? Yeah. That's right. That's why you guys did some numerical approaches. And so if x is bigger than 1, what piece do you use for the absolute value? The top. You guys use the top piece, which is really what? X minus 1. So we have x plus 1 x minus 1 over now what? X minus 1. And your x minus 1's cancel. So that's really going to be the limit here as x goes to 1 from the right of a what? X plus 1. So what do you guys know? What does that mean about this x? Plug it in. It's a nice polynomial function. And then 1 plus 1 is actually what? 2. Okay, so the right-handed limit is 2, the left-handed limit is negative 2. Then what does that mean about the limit? Does not exist. Yes. So they might even ask you to show it does not exist. Okay? And you say, well, what does that mean if they say to show that this limit does not exist? Well, it means you have to go through everything I just did here. You can't just guess. It's code for just don't guess. There's work to look at. And this is the work. But notice what's the key here. Right here is the key. You want to use that definition for an absolute value. So that's where the pre-calculus comes in, ladies and gentlemen, if you guys want to know the truth. And then it gets better. You say, what is it? What do you mean by that? Well, going back to the website and going to, you guys are in 261, going to the new Calculus 1 video library. I'm going to share with you something. See this worksheet called Limit Examples? I have additional examples for you guys here. Some are similar, some are exact, some are similar. Okay? So I also have here a video on those what? Those additional examples. So I'm giving you guys almost like double the examples of how to do the so-called algebra for some of these. Now, does that help you do some of the homework that you guys had? Should we try another one really quick, just for fun? Right, now that you guys are having fun, you say, okay, using some algebra, what if they give you here? This is another popular one. What's the limit as x goes to 4? The absolute value of x minus 4 over x minus 4. At least we can at least start it, right? What do you think that means again? What do you guys get? 0 over 0, and that's indeterminate. Is that right? So if it's indeterminate, what have we been saying today? What do we have to use? Use algebra. Okay. So the only algebra you guys can use is to define the absolute value of x minus 4. Is that right? So you say the absolute value of x minus 4 then is x minus 4 when x minus 4 is greater than or equal to 0. It is the opposite of x minus 4 when x minus 4 is less than 0. Is that right? Okay, you guys okay with that? You want to use this definition I gave you guys. This is gold. Right here is gold. That's what you guys are going to use. Okay. So, you just simplify this now. The absolute value of x minus 4 is going to be now x minus 4 using a little bit of algebra. Okay, and I'm going to keep this as in parentheses this time. Okay, so again, I'm going to have a top piece when x is greater than or equal to 4, a bottom piece when x is less than 4. All right. What's the problem with this limit question? It's at 4, which means I have to check both left and right. And that's kind of the exercise. So the exercise here is going to be, okay, the limit as x goes to 4 from the left of the absolute value of x minus 4 over x minus 4 really is the limit as x goes to 4 from the left. What does it mean to go to 4 from the left?
You have to go from negative
X is smaller than 4. Which piece is that?
negative x.
Is that the bottom piece?
Yeah, the bottom.
So you're going to say this is negative x minus 4 over what?
X minus 4.
And then this is just negative 1. It's a constant. So the limit as x goes to 4 from the left of negative 1, which will be what? It's negative 1. Okay? Because you got to use the right piece. It's going to be the bottom piece. That's all we did here. Because x is less than 4. Now, what about the right-handed limit now? You say, okay, the right-handed limit as x goes to 4 from the right, which piece do I use here? Why the top piece? Because if x is going to 4 from the right, all of those values of x are bigger than 4. Is that true?
Yes.
You're going to 4 from the right. Okay. So that means the top piece here is x minus 4 over x minus 4. I'm going to color it in gold. We use the top piece. Is that right? You guys see the point? And what does this become?
1.
Good. This is just the limit of 1. And the limit of 1 is a constant, right? Limit of a constant is the constant. So you found the left-handed limit, the right-handed limit. They're not the same.
Does not exist.
Does not exist. So there's your final answer. So let's ask you guys a question here. Are you better able to answer the homework questions on section 2 point what? 3, you think? What do you guys think? Are you guys better able to handle those? Now, of course, you guys can come to office hours if you have additional questions. You got your SI coach over there. You got the math tutoring lab. You got resources. But hopefully you guys are better able to answer those questions. Okay, we'll see you guys when? Tomorrow.